Hey, welcome back. Had to move around a little bit. Got a little noisy in the house. And yeah, hopefully it's not too noisy out here. Anyways, a couple reminders too before I finish up with the video for the notes for today. Don't forget to be taking the survey. Okay, survey on Wednesday. Please take the survey and let us know whether you want the grade for credit or if you want to take the class for a grade itself. All right. Oh, the other thing is, please don't forget about Desmos. All right, Desmos is a great opportunity. It's a great tool to use. You can always punch in your equations in here and see where, like I said, where these right here are called your x-intercepts, where your roots are, where your solutions are at. You can also tell where the y-intercepts are at too, as well. You can see if the equations match each other, like these two did. So Desmos graphing calculator. I know some of you guys use it. Some of you are a little unfamiliar with it. It's a great tool. Get familiar with it. Bookmark it as one of your bookmarks. I got mine right here with graphing calculator. So again, use that to your advantage there. All right, next up. Let's finish this up. And we were talking about vertex form. So don't forget the H is the X value of the vertex and the K is the Y value of the vertex. So if I'm going to use this to find or to write an equation in vertex form like it asks, then what I need to do is first find the axis of symmetry. And remember that formula is X equals negative B. In this case, the B value is negative 4 over 2a, and the a value is this shy guy. It's a 1. All right, so simplify that down. That's 4 over 2, which reduces to 2. All right, so that's my x value of the vertex. The y value, I find that out by plugging this x value back into the original equation. X is equal to 2 squared minus 4 times 2 plus 8. Y equals 4 minus 8 plus 8. Minus 8 plus 8, they just cancel each other out and leaves me with 4. All right, so what do I have here? I've got my x value and I've got my y value for my vertex. So if I'm going to write that in vertex form, that's my x, that's my y. It's going to look something like this. Y is equal to x minus, and my h is 2 squared plus, and then my k value is 4. Right? There's no need to simplify or clean anything up. And as you can see in this form, the x value of your vertex, it looks like it's negative 2, but it's actually the opposite sign of that. It's positive 2. And then the y value of vertex is just whatever this k value is, this number outside of the parentheses is. That's your y value of your vertex. Okay, easy enough. So let's do one more. X is equal to negative b. That's 10 over 2 times a, which is 1. That's negative 10 over 2, which is 5. So there's my x value of my vertex. My y value, plug that back in. 5 squared plus 10 times 5 plus 17. All right, my y value is going to be 25 plus 50 plus 17 equals 92. Big value, huh? All right, good thing we don't need to graph that one. So what is that going to look like for vertex form? Y is equal to x minus 5 squared plus 92. All right, and that's one way you guys can write this in vertex form. It says up here in the notes, you can see that you can also do that by completing the square. That's not anything I'm going to take time to go over with you guys right now, but that is another option. If you're familiar with completing the square, then by all means, please feel free to use that. All right, now this is just kind of repeating the same thing, but it's asking about finding the minimum value, okay, or the maximum value. Now, the reason that we know that this first one is a minimum is because the a value is positive. And with a positive a value, that means we have our smiley face. And a smiley face is always going to have a minimum. Whereas this is a maximum is because our a value is negative, and a negative a value, that's our frowny face, will always have a maximum. Okay, and remember, these maximum or minimums basically are the vertex, or they are the y value of the vertex. Okay, so all you're going to do is, just what we did with those other two examples. You're going to find the axis of symmetry. X is equal to negative b over 2a, negative 12 over 4, which is negative 3. Okay, so that's not my minimum value. That it will tell me what my minimum value is going to be. So now I plug that back into the equation. Y equals 2 times negative 3 squared plus 12 times negative 3 plus 13. All right, y equals negative 3 times negative 3 is 9, and 9 times 2 is 18. 12 times negative 3 is negative 36 plus 13. All right, let's combine these up. That's going to give me 31, positive 31, and a negative 36 is going to give me a negative 5. All right, doing that in my head. Am I right? Okay. All right, so that's what it was asking for, not the negative 3, not the negative 5, okay? It doesn't say write the equation in vertex form, but finding the vertex will help you tell what the minimum value is. So in this case, the minimum is equal to negative 5. So that's the y value of this, okay? The vertex was going to be located at negative 3 comma negative 5, okay? And again, you can tell me what that y value is. Minimum is at negative 5. Here we're going to have a maximum. X is equal to negative b over 2 times a, and the a value is negative 1. So what's that? Negative 2 over negative 2, which is positive 1. Y is equal to negative 1 squared plus 2 times 1 minus 4. All right, now the order of operations, we're actually using the exponents first. So this is 1 times 1, then multiplied times the negative sign. So this is negative 1 plus 2 minus 4, which is going to give me y equals negative 3. Okay, so that means my maximum value, max, is equal to negative 3. My vertex is at 1 comma negative 3, and that maximum value, that y value, is at negative 3. Okay, that's what that's asking for. All right, last one here. If we are going to write it in intercept form, okay, so this is intercept form. Remember the P and the Q represent our intercepts. Okay, if we were going to look back at graphs, remember intercepts. These are our intercepts right here at negative 3 and at positive 2 for this graph. Okay, this is intercept form. X minus 2 and x plus 3. Okay, notice that it says x minus 2, but the intercept is actually at positive 2. It says x plus 3, but the intercept is actually at negative 3. Okay, because what you're going to see in the intercept form is the x value will be the opposite sign of the number inside that parentheses. Both of the x-intercepts are going to be the opposite signs of the values you see inside the parentheses. All right. So how am I going to write that in intercept form? What we're going to need to do is we're going to need to factor it, just like it says. You have to factor the trinomial. So if you guys recall, factoring trinomials, I know some of you guys learn it different ways. I'm just going to set mine up this way. It's pretty quick. 18 and negative 11. All right, so what I'm doing is it's called a product sum table. Sometimes teachers write it like this, product of 18 and a sum of negative 11. Okay, that's what we're looking for. All right, well, I'm writing mine like this. And what two numbers multiply to 18 that add up to negative 11? Well, both numbers have to be negative in order to multiply to positive and add up to negative numbers. So we know they're both going to be negative. And what are the multiples of 18? Well, we're looking at 1 and 18, 2 and 9, 2 and 9, because 2 plus 9 is 11. Negative 2 plus negative 9 is negative 11. Multiply those together, you get positive 18. So there you go. So when I plug these in, y equals x minus, all right, these are my winners here, and these are what I'm plugging in. So this is going to go in as negative 2, and this is going to be x minus, and this will be negative 9. Okay, we will never leave it like this. You always need to clean it up. Anytime you have a minus and minus next to each other, what's that going to turn into? Bam, bam, plus, plus. So that's x plus 2, minus and minus, bam, bam, plus, plus, x plus 9. There is our intercept form. And the x-intercepts are at the opposite of this, negative 2, and the opposite of this, negative 9. All right, let's try one more. Two numbers that multiply to negative 8 that add up to 7. What numbers multiply to negative 8 that add up to 7? What do you think? Oh, one's got to be positive, one's got to be negative in order to multiply to negative 8. And adds up to positive 7. Negative 1, positive 8. There we go. Negative times a positive is a negative. Negative 1 plus 8 is positive 7. Winner, winner, chicken dinner. So this goes in here like this. Y equals x minus negative 1, x minus positive 8. Minus and a minus, bam, bam, plus, plus, x plus 1, x minus 8. There you go, intercept form. Okay, so, oh, sorry there. Hope that was helpful. And there are, this is, yeah, more practice problems. So if you guys have any questions, please let me know. And don't forget to fill out that survey. And tomorrow is a unit activity. When you guys do your unit activity, please make sure you guys cover everything in the rubric. I'm actually grading that personally. I want to give you guys maximum points, and I can do that as long as you guys are covering everything in that rubric. So do the best on that, and I know you guys will do well. All right, take care. Bye.